Now coming to the next additional form of proof, proof by contradiction. So here if A then B. We start with statement A is not true. So how do we do it? We take the contradiction. We start with statement A is not true. Statement A is not true. We try to conclude statement B. When it becomes impossible to reach the statement B, then we contradict and accept that A is true. Here we will prove that root 2 is not rational by contradiction method. We are going to prove that root 2 is irrational by contradiction method. So what is the first step in contradiction method? We take the statement and we write it in the negative way. So assuming that root 2 is rational. Assuming root 2 is rational. Now what is rational? It is in the form of A by B. Okay, it is in this format where B is not equal to 0. Okay, denominator is not equal to 0, and A and B are co-prime numbers. Now, what is a co-prime number? Because it is a rational number, I'm going to take the least form of A and B. Co-prime numbers are, this A and B will not have any common factors. No common factors. So this is a rational number. So what is a rational number? It is a real number. So it will be in this format, a fractional format, A by B, where the denominator is not equal to 0, and A and B, these A and B will be co-prime numbers. So what is a co-prime number? A and B won't have any common factors except 1. Okay, it won't have any common factors except 1. So we are taking that root 2 is rational. So how can I write it? I'm going to write root 2 is equal to a rational number A divided by B. Okay, now I'm going to square on both sides. Squaring this expression, say this is 1. What will I get? 2 is equal to A squared divided by B squared. So 2B squared is equal to A squared. Now what is A squared? A squared is 2B squared, which is a even number. So A squared is even. So if A squared is even, A is also even, right? So if I take 2, 4 is also even. If I take 4, 16 is also even. If I take a 10, 100 is also even. So squares of even numbers are even. Alright, so A is also even. So this is done. Now I'm going to take, we know that since A is even, I'm going to assign a new variable k, even variable to k. I want to find this B. Okay, so that is why I'm taking a new constant 2k. I'm assigning one value for k. So I'm going to substitute this in this equation. Say this is 2. Substituting above in 2. What do we get? 2k the whole squared, okay, is equal to 2b squared. That is 4k squared is equal to 2b squared. Now what will be b squared? B squared will be 2k squared. Correct? So this and this will get cancelled. So 2k squared. Now I've got, now I know that b squared is even because I have 2 here. Any multiples of 2 will be even. So b squared is even. So when b squared is even, I know that b is also even. So now what is happening? We have found that a and b are even, but rational numbers, it cannot have common factors, right? Now we have common factor 2 for both a and b since they are even. By 2, a and b are not co-primes. Therefore, not rational. Therefore, root 2 is not rational. Hence the proof. Thank you.